So those of you that are watching at home, I've got our 3 warm-up questions for the lesson. We're doing more examples in section 9.2 on completing the square. And as y'all warm those up, I will be right back. I gotta fill up my hydro jug. All right. So we've had a little time to get warmed up. Y'all might still be working on this. But let's talk about number 1, simple little FOIL problem there. Joe, you want to take that one? What'd you get? Good, x squared plus 18x plus 81. Now, we could write that up as a FOIL problem, or we could remember our shortcut, which is to square the first term, square the last term, double the product. And then the inverse of those operations are what we're going to be going through when we're doing this completing the square process that we introduced on Tuesday. Did you hear what I said? Square the first term, right? So when we're completing the square, oftentimes we are considering, what's the square root of that first term? When we are squaring the second term, again, we're looking at, thinking about the square root of that 81. And then when I say double the product, oftentimes, that inverse operation of doubling something, what we're looking at is cutting it in half, right? So we take that 18 and we cut that in half. Remember that from your completing the square steps. All right, George, you want to do number 2 for us, please? Factor out that PST. Good, and we'll say y minus 7 quantity squared in this lesson because we're going to apply that square root method to that example. And Jack, what do you got for number 3, factoring that out? Nick B? Have you got the first step out of the way? Oh, you went ahead and jumped on into the magic method. What method should I look for first before I try magic method, Paul? Take out a GCF. So if I take out a GCF here, I take out a 5, I'm left with n squared plus 8n plus 16. And now, Jack, that becomes much easier trinomial to factor. Actually, that is a PST. Go ahead and factor that out for us.
4.
So n plus 4 quantity squared. Fabulous. So we're always on the lookout for a little GCF action as need be on these factoring problems as well. Okay, so any questions you guys have over the 3 warm-ups? Talking about FOIL, factoring, PSTs, all that good stuff. A little review for us. Okay, now I will remind you of the step-by-step process that we started on Tuesday, right? You look at the top of your screen right here. We've got steps 1, 2, and 3. And we said this process is known as completing the square. This process called completing the square is where we take something that is not a PST, something that is not a perfect square trinomial, and we make it 1, bless you, so that we can factor and then use the square root method. All right, so like we went through with the red one here on part A, and we said, what would make this a perfect square trinomial? We said 9 would. And then the blue one, we said 121 would, right? The reason that we got those two numbers is that we identified the linear coefficient, we cut that in half, and then we squared the result. So we took that 6, cut it in half, got 3 squared is 9. 22 cut it in half, got 11 squared is 121. All right. So, Alex, you want to do the green one, part C? What am I going to get there in that blank? Walk me through my process. Talk me through it, and I can help you as need be.
30, which is 17.
Mm-hmm. And we get 289. Very nice. Okay. And then how, Nate, how's that going to factor now that Alex has written it as a perfect square trinomial? We're going to have what over there in the parentheses? Yeah, very good. X plus 17 quantity squared. Okay. It's just that simple. Now, part D is a little bit tougher, and so I'm going to let you guys chew on that one. I'll give you 60 seconds, okay? So we see this pattern where we're picking up today with the red and the blue and the green, okay? So now we're looking at this orange one here, and it's going to be just a little bit more challenging, but we can still do it. Okay. Got about 30 more seconds. What goes in the blank to make it a perfect square trinomial, and then how would that factor out? And again, just follow your steps. Step 1, step 2, step 3. All right, Alex, can I again, like I asked Mr. Went up here, can you walk me through my process? What do I do first? Excellent. Now, class, when we cut, as Alex said, when we cut 3 in half, how do you think we should write that? Anybody that has a comment, throw it out. Very good, very good. My freshmen yesterday when they were doing this, kept wanting to give me what? 1.5, a dirty old decimal. And then, so if I can leave it as a fraction, my next step will be easier. Alex, go ahead. When I take 3 over 2, my next step would be to square that. And 3 over 2 times 3 over 2 gives me squaring. You added 3 plus 3. I want 3 times 3. 9 over 4. Yeah. And that is now a PST. Now, this kid yesterday that was doing it, he told me 2.25, which is 9/4, right? But if we avoid the decimals, we're going to avoid a lot of headaches because although 3 over 2 is an easy decimal to square, right? Everybody should know 1.5 times 1.5 is 2.25. All right, because we know what 15 squared is. But like imagine what if this was like 37 or something like that? Right? How the dump am I going to figure out what 18.5 squared is? I'm not. So leaving them as a fraction will be much more likely to find success. All right. So Charlie, how would that factor out now that Alex has set that up as a PST? Perfect. Very good. Very, very good. So what we're doing with completing the square process is we are turning something into a factorable trinomial. Okay. I hate that fake sneeze. I normally sneeze in twos. Do y'all ever sneeze in pairs? I normally do. And the last couple times I've tried sneezing, I'll get one out and then I'll be like, ugh. The rest of this ain't happening. All right. So look what I've got here on the screen. We're going to do an example in blue. And sort of in the background, what I'm going to have you doing is following some basic steps in orange. So like the example is going to be worked out in blue, but like the process that we are following, I've got outlined in some steps like a step-by-step approach in orange. Because what we've looked at up to this point in the section is we have been dealing with just some random expressions, and we've been kind of playing around with those expressions and not really following any rules of algebra. Like we've just been randomly adding 9 here, or adding 81 there, or adding 289 here. We can't just add something whenever we want to, okay? In an equation, if I add something on one side, I have to do what? Yeah, I got to add the same thing to the other side, okay? So suppose I give you this quadratic equation, x squared plus 6x plus 2, all right, equals 0. Now, up to this point in the year, Quentin, what's been our only technique for solving quadratics? And then F word, factor, and class use the zero product property because we've set it equal to 0, right? So up to this point, that's been the only way to do it. Candiato, can I factor that in blue? No, there are not two factors of 2 that add up to equal 6. And so we're like, I'm stuck. Well, stuck we are no longer, because we are going to move that 2 over to the other side. That's your first step. Move that constant term. Move C over to the other side. And we now have a little blank, okay? Grove, beard stroke. What do you think is going to go in that blank? Y1. Threw me a curveball there, boy. I wasn't expecting the number 1, considering what we just got through doing in all 4 of those, right? And in fact, part A is the exact same thing. So, you want to try again? What goes in this blank right here?
Product of 16 squared.
Which would be?
9.
Correct. And then class, what did y'all just say about 2 minutes ago? If I want to add 9, which Grove has correctly told me to do on the left side, what must I also do? Add it over to the right side. All right. So I'm kind of holding your hand along through this first example of solving an equation using completing the square. And then, so we've done our CTS. We've done our completing the square. Now we want to factor it. Okay. Will Edwards, can you be a factoring man for me, please? X plus 3 quantity squared. And last time I checked, negative 2 plus 9 on the right-hand side is 7. Now this equation has been transformed. It has been changed from that standard, at what we started with, ax squared plus bx plus c equals 0, where we think, I'll factor and use the ZPP. It has been transformed through completing the square to an equation now that I could use what method for? The square root method. I could take the square root of both sides, which is what we practiced a buttload of problems on in section 9.1, right? I could take the square root of both sides, and I get x plus 3 equals what? Good. Plus or minus. I've been really busting my freshman's chops on remembering their plus and their minus, because what kind of equation is this, class? It's a quadratic equation. And what does every quadratic equation have? 2 solutions. Very good. All right, so we got x equals negative 3 plus or minus square root of 7. All right. And so then I asked the question, what kind of scenario are we dealing with then? Look over on the right. If we were talking about the graph of this parabola, x squared plus 6x plus 2, let's say that's our function, f of x equals that. All right. Would that parabola pass through the x-axis twice at 2 different points? Would it pass through the x-axis no times? Or would it pass along and hit the x-axis once, being a double or multiple root? What do you think, Jack? All right, so that first one, does anybody agree with Jack? Does anybody disagree with Jack? Does anyone not know? Okay, so the not knows is the most popular one. So let's talk about what we've just found. What we've found down here, we solved this equation, so these are our solutions. What's a synonym that I've taught you for the word solution? zeros, roots, or graphically speaking, x-intercepts. How now, brown cow? Negative 3 plus the square root of 7 is about negative 0.354 dot dot dot. Negative 3 minus the square root of 7 is negative 5.6457 dot dot dot. Whatever. These are two distinct real numbers, right? So which of those scenarios do we think? Our x-intercepts, there are two of them, and that's that top scenario. Now I know I probably should change my y, where my y-axis is on that. Let's do it. All right. There we go. That looks a little better. Okay, because it's hitting the x-axis at these two negative values. Those are our roots, solutions, zeros, aka x-intercepts. All right. And now, congratulations, you guys have solved your first big boy equation that was not factorable. You made it factorable by completing the square, by turning it into a perfect square trinomial. So like, check this out here in green. What you did was you took something that was not factorable, and because it's an equation and we can do whatever we want to on the left as long as we do it on the right, we completed the square, turning that into what I've got highlighted in green as a PST. Come on, baby. Now we're ready. Y'all want to try another one on your own? Follow your steps. Move your constant over. Fill in the blank. Make sure you keep things balanced. Do what you do on the left and the right. Factor as a PST. Use the square root method. Don't forget your what? Don't forget your plus or minus. Paul, pull your mask up. Seeing some good work, boys. I like it. Tiago, I know you're still writing, but tell me my first couple steps. What'd you do? You did what? And got? Okay, good. So you just say plus 25 on both sides. Good. I wasn't following what you were saying to begin with, but there you go. And actually, you answered my next question I was going to ask. Where in the dump did that 25 come from? We took the linear coefficient of 10, cut it in half, ding, squared it, and got 25. And whatever I do on the left, I got to do on the right. Joey, do you have a question? All right, then follow up. What do I do next? So factor the left side as what? X minus 5 quantity squared, and then your next step? Take square root of both sides. When I take the square root of both sides, I need to remember a what? Plus or minus. Very good, very good. Andrew, can you simplify the square root of 28? Fabulous. So I'm going to have plus or minus 2 square root of 7. I would venture a guess that some of y'all forgot to simplify the square root of 28. Okay. Let's make sure we don't forget that. And then the last step would be to add 5, and so we got x equals 5 plus or minus 2 square root of 7. Fabulous. You guys are rocking and rolling. I like it. Completing the square. Any questions on example 4? Have y'all done this in y'all's class yet? Some have not. Some maybe don't know. Okay. So let's try another one. Practice, my boys, practice. We talking about practice. You guys that are watching at home, I apologize. I'm fixing to jump screens on you just for a sec. All right, perfect. All right. Hold on. Come on, baby. Now we're cooking. All right. And we're back to where you should be. Thank you for your patience. And you guys have a Delta Math assignment, by the way, talking about practice on this very topic, right? Where, and I haven't checked to see who's done it and who's not, but you're going to get, buku practice examples on completing the square. The more you do this process, the better you'll get at it. All right. I'm gonna go straight to excuse me. I'm gonna go straight to the cut to the chase, James, and say what were your answers? Only thing I'll change is I'll say let's divide both of them by 2. Now, does anybody concur with that answer? Does anybody agree? Say, that's what I got. All right, Jack. Jack, if you put your hand in there, that means you agree. You can. Oh, hold on. I'm frozen. Y'all can't see what I wrote down. There you go. Jack, do you concur or do you not concur? You do not concur. Okay, Jack, what did you get? So you had a 5 over 2 and a 21 over 4? So that must mean you had a 10 over 4. All right. Does anybody concur with that answer? Candiato does. Okay. Anybody get anything different? This is interesting. I like it. All right, Grove. Line her up, big boy.
I got x equals 5 over 2.
All right, so that's going to be a 10. And what was your radicand?
6 over 4.
Square root of 6 over 4. Anybody concur with that? is excellent. We've got 3 answers, none of which we have a widespread concurrence on. So what tells me, what this tells me is that we need to go through on a nice step-by-step approach and see if any of these are correct. All right, so my first step is going to be to subtract 1, correct? So I'm going to get a little space. So x squared plus 5x equals -1. Now, Drew, what makes my next step challenging? I think we talked about this on Tuesday, perhaps. Or no, actually, we did not. This would have been in line with the part D right here, with that odd linear coefficient. What makes this challenging? Speak up. Yeah, we're going to have a fraction, in other words, right? Should we be scared of fractions? No, don't be scared. Fractions are fun. So I'm just going to take 5. I'm going to cut that in half and get what? Don't you dare say 2.5. 5 halves. And when we square 5 halves, we get, did you say 10 fourths? Someone said 25 fourths. That's what I want to see, 25 fourths. Remember, when we square something, we're not doubling it, we're multiplying it by itself. All right, so 5 cut in half is 5 over 2. 5 over 2 times 5 over 2 is 25 over 4. But whatever I add on the left, I must also add on the right. So plus 25 over 4. Okay? Now the left-hand side is going to factor out like it always does. In this case, it's going to be x plus 5 halves quantity squared. Okay, I think we've been around that type of example enough to know how it factors out. If you're still struggling with the PST factorization, I would say, split both of those up as we've been doing, and, circle, 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 just like we always do. Okay. What do I need to do on the right-hand side, Jake? What do I need to do, though? I'm saying, what's -1 plus 25 fourths? That's because we need a CD, a common denominator, right? If you're going to add 2 numbers together, one of which is a fraction, you better make sure that they both have the same denominator. All right, so that's going to become 21 fourths. Okay, so I'm starting to think on that last one. Sorry, Grove. Still love you. Now, what do I do to both sides? Square root method, right? So we take square root of the left, square root of the right. All right, so we got x plus 5 halves equals, don't you dare forget it. Don't you dare forget it. What goes in front? Plus or minus. All right, now read. Here comes a tough question your way. How do I take the square root of a fraction? You take the square root of the top and you take the square root of the bottom. Very good. Now the square root of the top, does that simplify any, class? 21 does not have any perfect square factors. The square root of the bottom, does that simplify? Yes, it does. Square root of 4 is 2. So whoever gave me that one, sorry. I still love you. Now that we've knocked the stank out of here, and that sweaty, musky kind of hotness up in here, I figure, you know what we'll do? We'll turn it back up. So now, last step was going to need to be what? What do I do to both sides? Subtract 5 halves. So I got x equals -5 halves plus or minus square root of 21 halves, which is right here, winner, winner, chicken dinner. Whose answer was that to begin with? Is that James? That our boy James. Hey, brush off them haters. Now look, if you've done, I always tell all my classes this, if you've done your job correctly, now I've said that twice, so I would probably write this down. The denominator should always be a perfect square, and therefore you should not have a radical left in the denominator. That's the first thing to jot down. If you've done your job correctly, this denominator is going to be a nice number. Okay? Second thing, if you've done your job correctly, should happen is that that nice number should match this nice number over here. Did you notice that? These two denominators, if I've done my job correctly, should already be the same by the time I get to that last step. So that I can do what with my final two terms? I can put them both together and express my answer as one big fat fraction. That's the convention that we follow. We don't leave them split apart. So like I think when a couple of you guys were telling me y'all's answers, you had -5 halves in front, and then you had your other fraction with a denominator of 4, and I'll let the cat out of the bag. I already knew those were wrong because the denominators, if we've done our work correctly, should be the same. Okay? So this is one of your harder completing the square problems, okay? Because it involved a fraction. A fraction occurs when that linear coefficient is ODD, all right? You're going to have a fraction when that linear coefficient is odd. Now, the only other thing to make this a little bit tougher would be if I had a quadratic coefficient other than 1, okay? But we're out of time for today, so I'll have to save that toughie for another lesson. Y'all have a wonderful day. Do some Delta Math homework and live Jesus in our hearts. All right. Y'all be safe out there on the road. Thanks again. All right, fellas. Y'all take care.